here we go. Good. So let's get started. So RAP has been around for a really long time. And we sort of pioneered quite a few things at Eclipse. So Eclipse was the first runtime project. At the time when Eclipse RAP was created, there were no runtime projects at eclipse.org. That's almost 10 years ago. And the Eclipse board, which at that time I was a member of, we took the decision that runtime projects are also welcome at Eclipse. And basically the technology for RAP has been around before, but we adopted the SWT API and created that idea of RCP on the web. So that was in the beginning of the RAP project. And it took us a couple of years and a couple of releases to make RAP stable, mature it. Commercially hardening was a really big thing, and nowadays RAP is used in many products and many projects without major problems. I think we can say that. It has a certain architecture, and it's not the right choice for every problem. I think you know that no technology is the right choice for every problem, but people that are using it are usually very happy with it. A couple of years ago, we decided to take RAP to a new level. That was when we released the version 2.0. And the main difference between all the 1x versions and 2x versions is that we standardized the data exchange between the client and the server. In the early days, it was just JavaScript that we were sending over the wire, and we decided to introduce a protocol, a formal protocol that's based on JSON. So that maybe doesn't sound like a big deal, but it enabled us to build other clients than the web client. And it made the web client also faster, easier to debug. We've been able to improve performance with that move as well. And during that time, the adoption of RAP really, I don't want to say went through the roof, but it became very, very broadly adopted. And one example of late, the SAP has just proposed a new project under the cloud tooling top-level project that has just been created. That's called Dirigible, and it's a web-based tooling that uses RAP as one of the technologies to bring the editing features to you in the browser. Right now we're working on RAP 3.0, and with RAP 3.0 we decided to adopt the E4 technology some more. That was a missing piece in RAP for 2 or 3 years. I think it took the platform quite a while to mature, and the first versions of the 4 line of Eclipse haven't been as stable and as reliable as probably everybody would have wished it to be. But that's always the case if you make a breaking change and develop something pretty new from scratch. It takes a couple of years to mature. And we think that the platform is now at a level where you can adopt it as a runtime. And so we're moving into that direction as well. And we plan to support and continue to develop RAP for a couple of more years. Actually, it's quite amazing that, I mean, the very first beginnings of RAP, technology beginnings, were in 2002. That's 12 years. That's really a long, long time for technology. And we're very proud that it still matters. A lot of technology doesn't matter anymore 12 years after you first created it. So that's something that's pretty cool. Let's see if we can get to 20, and I'm pretty positive that this will be the case. So maybe a little bit outside of the radar of many of you who are users of the open source technology, there are a few things that we do on the commercial side, and I just want to give you a brief overview, and then we do more of the fun stuff and the demos of cool technology. As every project, RAP has bugs, and sometimes we are not as responsive. If you plan to deploy RAP, you can basically get a priority or dedicated time for fixing a bug if you get one of our developer support packages. So we do that with sponsored development. I'll go into that in a moment. So if we look into single sourcing, it's always amazing, and I've seen that many times, that within a week we've always been able to show a proof of concept of an existing RCP application on the web. And if you see that for the first time, that's obviously not working for production needs, but I mean it shows you what's possible. And so it has been all different sorts of apps that we've been getting to work with within a week, from insurance apps to inventory control systems and so on. Another element of our offering that's actually quite often used is what we call sponsored development. So RAP is missing features even after many years of development, and if you really need something for your project to work, because we don't cover the entire APIs that SWT and Nebula and everybody is using in their projects, so you can basically pay for open source work. Just two popular examples here. One is the Nebula Grid. So that has been ported to RAP as part of a sponsored development contract. And I mean, the good thing is you get a deadline, and the community gets the open source code, and everybody profits. Another example was a drop-down or type-ahead search that was a feature missing from RAP for quite some time, and has been added by sponsored development. So just a brief look at the different packages that we're offering. So the smallest package that we offer is the starter package, and basically it buys you some time from from RAP experts, and you can use that for various tasks to perform. Yeah, for example, doing a small custom widget, or just the proof of concept that I mentioned earlier, or a workshop, for example. And we have a couple of those packages. You can find out more if you're interested. So hand in hand with the developer support, there is something that we've been working on with the Eclipse Foundation, which is called long-term support. I actually prefer to call it long-term maintenance. As you all know, Eclipse only provides 2 service releases. So there's a release SR1, SR2, and that's it. So that's usually 9 months of support that you get for a given version. For sure, you can update to the next major release, which is a year later, but sometimes you cannot really continue to use new projects or new versions, especially if there are major versions upcoming. I mean, we take API compatibility very seriously, very, very seriously. But still, sometimes you need to break API to make new things possible. And we only do that with major releases. But as it happens, if your project or product is affected, you have to ask yourself the question if you want to upgrade to the latest version, or if you want to continue using an old version. And with a technology subscription, you get more service releases. And so what do we do there? We make sure that the latest version of the supported browsers are still working with that version of RAP. And we do backporting of security fixes. So technology subscriptions can be part of a developer support package, and they are part of all the production support packages. And production support, yeah, you can guess what that is. So, okay, now moving on to the fun part. Now we get into technology. We're not only doing services around RAP, we also offer technology that's based on RAP. And one that you probably have heard about is Tabris. And now try to get my phone to work. Tabris is a runtime that's replacing the browser for us on the mobile device, but executing the JSON protocol that the RAP server is sending. Yeah? So you continue to develop your client in Java on the server, but now you can run the user interface not in a browser on the device, but on a native environment that we created that runs on the device. And let's see. There we are. So now, here we go. Let's start with something that's a little bit fun. Lots of applications can be built with labels, buttons, images, lists, and so on. But mobile devices have more features than that. For example, you can send something to the background. So now I send Hal to the background. So let's wake him up again. Yeah. So now I woke him up again after 8 seconds. So I can be beyond those APIs that make up a UI. We also offer features that allow you to interact with the device itself. So we know if you're on background, foreground, geolocation, camera, all those things that do not exist in SWT because you don't need them on the desktop, or we didn't need them in the past on the desktop. And so that's available on SWT. But where it really shines, I'll show you that as well, is, for example, if you're working with large amounts of data. My device is a little bit, so I threw it on the floor yesterday and it didn't like it. So have you heard about the Enron Data Set? So that's a set of the Enron scandal. Probably most of you know that. They had to publish all their emails, or large parts of their like the company emails, and that has been put into the open domain or public domain. And those are 500,000 emails. And now that's a 3G connection. And now I'm accessing on our server, where the 500K emails are stored, I'm accessing 500K emails. And the entire implementation for that fits on 2 pages. It's a tree, a virtual tree, and one more shell that's showing that email. That's it. So it makes it really easy to work with large amounts of data if you want to keep that data on a server. So for example, in clinics, this is very popular, where you don't want to put data on the device because devices get stolen, and if you have sensitive information, that's not fun. So that's let's turn it off again. That's Tabris. But we do more than that. And that's probably the funniest thing that we did in the past. We created a desktop client for RAP. And it's really funny that I'm impressed every time I see it. So that's the RAP controls demo. That's rendered with SWT. Yeah. Let's pick some more things. Let's take the dialogues are fun. Here we go. Or a scale. Or the tab folder. So now, why on earth would you run an application where you basically that you could deploy directly on a device on a server and then use a desktop client to connect to that server? Sounds pretty strange, but there are use cases for it. For example, if your devices are not very powerful, and if they don't allow you to use browsers, I mean, modern browsers are blasting fast on the kind of hardware that we are putting on our desks. But if you think more into the embedded space, those devices don't have a lot of horsepower, and running a browser and a lot of JavaScript on those devices is not very powerful, or it's not very fast. SWT has a pretty small footprint, and you can achieve really nice results on those devices. Another area where you can use it is if you have local integration, if you need to integrate with hardware that is attached to that computer. Yes, it's possible from browsers, but the main idea behind the browser was that it's a sandbox, and yeah, that you shouldn't be able to get outside of that sandbox. So local integration of stuff is always hard with browsers. So that's not a product yet, but I think that was the first time that we showed that publicly. But it's fun. So, oops, there we go. Just coming into sight. So that's something that we're working on, that we have been working on with a large team. And that's a new life for SWT. Not in the sense that maybe some of you would expect. So that's typical SWT code. That's look just briefly what we're doing here. So creating a button, setting a text, and adding a listener. Yeah. So over the wire, if you run that on a RAP server and connect the device to it, the device is instructed with a JSON array of instructions, and that JSON here says create a button. It has a parent. The style of the button is a push button. It has bounds, so it's placed somewhere on the screen. It has a tab index, and it has a text, which is hello world. And we also attach a listener on that same button for selection true. And basically what we've been working on over the past couple of months is creating a JavaScript API that allows you to run an application completely locally. So we have focused on mobile devices for the moment, not on the browser, but we have that also working in the browser just for a subset of the stuff. So now we can create a button in JavaScript. We lay it out, we set a text, we attach a listener, and we append it to a parent. And I just want to give you a very brief demo of what you can do. So here we are back. And so we built a little example. That's the iOS 8 weather app. And if you move that, you see the temperature disappears. You move further up, and now the days slide under that hourly preview that you get. And that all bounces and flashes and yeah. So can you do that in RAP? That's just a mock, yeah. Was not our goal to build an entire weather app with it, but it's 150 lines of code, and see the temperature disappears. We're moving up. Content moves below that list. It bounces. It's absolutely smooth, just like a native app. And now looking at the code, let's turn that off again. So that's written in JavaScript and written and deployed in JavaScript to the device. Maybe we zoom that a little bit for you. Just, you see the data is all static. The interesting part happens here. So let's have a look at a composite that we're creating. Var our composite equals Tabers create composite. It's a scrolled composite. We can scroll it horizontally. We have layout data, so that's a sort of what's that relative layout in SWT called again? Getting old. Form layout. Yeah, sorry. It's a form layout. It's a form layout-like mechanism. And one thing that we have in here on the device is we have transformations. SWT doesn't know that, but you can basically scale and rotate and put offset stuff from where it really is. But it looks pretty familiar. Tabers create label, text, day, foreground, white, and layout data, and so on. And now the fun stuff is happening down here. So we have that scroll composite, and the scroll composite has an event on the scroll, and everything that we do here is, that's calculating the offset, how much we move things up and down, and then we are setting the opacity and setting the transformation on two composites. And that's doing that effect that we've seen while we're scrolling. We're updating the position of certain elements on the screen, and we can do that as often as 120 times per second. So everything is running on the device, and the performance is so amazing that we can really do animations and like finger-led transitions just the way that native applications can do that. So actually should be coming to an end. Yeah.
But how much wrap is in there?
How much wrap?
Yeah.
It's the same client. It's the same client that renders this server protocol. Is rendering the JavaScript natively.
Well,
so
but does it still need the server part of the
it doesn't need the server, so that's the wrap part in there is the client.
Okay.
It's not the server. I mean, wrap is a server and JavaScript code that is rendered on the client, and then we went and replaced the browser with something native, and now we basically replaced the server with the ability to write JavaScript. So where does that get back to wrap? We basically want to integrate those two things, so that you can run stuff on the server, but still, we all know that sometimes you need local interaction. And we've done something like that with client scripting, but sometimes you need more. And if you are able to write an entire component in JavaScript that behaves like a local component, and that you can call from the server like any other widget, that's pretty cool, isn't it? And we will make that available also in the open source space for the browser. So then you can write in normal JavaScript, you write a component, and you can call it from the server like you do with any other component. Okay, the time is over. And the talk is over. Do you have more questions? Okay. Have fun at the conference. Bye.